The continuation of the question. This was the last question I was discussing. Like when we need the shaded area, the shaded area was whole area minus the slotted area. The whole area we calculated by pi d square by 4, and slotted area we already did like a into b, that was 1.03. So when we did this, it was coming out as 10.4 centimeters square. Then uncertainty in value of a shaded area. So how shaded area is calculated? The shaded area is calculated by whole area minus slotted area. So first what we'll do, we'll find the percentage uncertainty in whole area. Then we'll find the percentage uncertainty in slotted area. Then this percentage uncertainty will convert into uncertainty of whole area, uncertainty of slotted area, and uncertainty always add. Even quantities are multiplied, divided, subtracted, added. Uncertainty always add. So we work out the uncertainty in whole area because whole area is pi d square by 4. So the percentage uncertainty in D was the smallest value, which was 0.05 divided by value recorded into 100. But if it is D square, then this will be multiplied by, if it was D cube, multiplied by 3. That's how we got the uncertainty, which was 0.26%. And then we find 0.26% of the total area to get uncertainty, because the whole area was 11.4. So when we take this one, we got 0.03. And then uncertainty in slotted area, we already calculated in the previous part, that was 0.02. So if this was 0.03, this is 0.02. What is the total uncertainty in the shaded area? That is 0.03 plus 0.02, that's 0.05. Is it clear, this one, about the uncertainties? Then the next one, student use a micrometer screw gauge to measure the thickness T of a slotted mass. She obtained the following results. Calculate the density of a metal in gram per centimeter cube and assume that the value of a mass is 100. So different values are there. A student is having a mean that is in millimeter, but we need gram per centimeter cube. So we have to convert the millimeter into centimeter. And density is mass over volume. The mass is already given. The mass is there, which is 100. Now, how we can work out the volume? Volume is actually, we have like example, this is when we look from the top, a 2D area was there. But if we look from the sideways, how this slotted mass will appear, so this will appear like this. So this is the thickness of a slotted mass, T. Now to work out if you want to work out the density is mass over volume. So mass is equals to 100. Now how to work out the volume? Volume is area multiplied by, like we should have area multiplied, like this is thickness is there. And if I have this whole area, like if I have the thickness, this thickness C is there, and I have the area. So if I multiply area with the thickness, I will get the volume. But what area I will take? What area we should take? We should take an area for, because the shaded area only, we should take an area which was 10.4, because that hole is not having a mass. This So this part was missing. So we have the area of this part and we have the thickness. So area of this part, shaded region, was 10.4 centimeters square. Thickness is in millimeter. We have to convert into centimeter. So it will be 1.137 centimeter. So mass is equals to 100 and the volume is equals to 10.4 times. Why 10.4? Because area multiplied by height or area multiplied by thickness will give us the volume. So 10.4 times 1.137. This will give us the density as 8.47 gram per centimeter cube. So this is the total density of a slotted mass. Calculate percentage uncertainty in density. So how to calculate percentage uncertainty in density? How density is calculated? Density is calculated by mass over volume. In the mass, they mentioned that mass does not have any uncertainty. Like at this point, the mass with an assume that the value of a mass is 100 gram with a negligible uncertainty. So mass does not have any uncertainty. But how volume is calculated? Volume is calculated by area multiplied by thickness. And what was the uncertainty in area, the unshaded area? The unshaded area that we already calculated, we can use that value, or you can also work out. Like we'll find the percentage uncertainty in not unshaded area, the shaded area, and we'll work out the percentage uncertainty in thickness, and we just sum them, we'll get the total uncertainty. And this area, when we calculated, this area was 10.4 with an uncertainty of 0.05. So what will the percentage? Look, when quantities are multiplied, two things you have to just remember. When quantities are multiplied, you will first get the percentage uncertainty and add the percentage uncertainty and then find the total. But when quantities are subtracted or added, find the percentage uncertainty, then uncertainty, and then add to get the total. That is a main difference. Like previously, if you check the previous part, when we calculated the whole area minus the slotted mass area, we'll get the shaded area. So here, because the quantities are subtracted, we first calculate percentage uncertainty, then we calculate the uncertainty of each of them, and then we will add. But when quantities are multiplied, that case, you don't add the uncertainties, you just get the percentage uncertainty and add the percentage uncertainty. So area of the shaded part was 10.4 with the uncertainty of 0.05. So what is the percentage uncertainty in shaded area? That is 0.05 divided by 100, multiplied by 100 divided by 10.4. So this will be 0.48 percentage uncertainty. What about the uncertainty in thickness? So for uncertainty in thickness, whenever you have a group data, for a group data, what we do, it is maximum minus minimum. Whenever you have a group data, the formula is the maximum minus minimum divided by 2. That will give us the uncertainty. And then to calculate the percentage uncertainty is a uncertainty divided by mean into 100. That's a formula to calculate the percentage. So first the maximum minus minimum divided by 2. The maximum value in this result, if you convert the unit, that is also fine. If you don't convert the unit, that's also fine because you are taking a percentage. It won't make difference if I don't convert the unit because it will give the same result. In terms of, so maximum is 11.39, minimum is 11.35 divided by 2. This will give us the uncertainty, which is 0.02. Then to calculate the percentage uncertainty, 0.02 divided by the mean. The average was 11.37 into 100. So this will give us the percentage uncertainty in the thickness, which is 0.18. So 0.18% uncertainty in the thickness and 0.48% uncertainty in area. So what is the total percentage uncertainty? The total percentage uncertainty in the density will be equal to 0.48 plus 0.18, that is equals to 0.66%. So this is a total percentage uncertainty. Is it clear, this part about the uncertainty? Then student think that slotted mass is made from brass. The density of a brass is 8.5. So determine whether a slotted mass could be made from brass. So if we want to, like the density of a brass is this, and our value for the density was 8.47 gram per centimeter cube. So what we usually compare, we compare the percentage uncertainty and we compare the percentage difference between the two values. If the percentage difference, like what we do, we usually calculate the percentage uncertainty and percentage difference. If the percentage difference is less than the percentage uncertainty, like percentage difference, if the percentage difference is less than the percentage uncertainty, it means they are made from same material or values are same. But if the percentage difference is more than the percentage uncertainty, in that case, they are not same. So whenever you're comparing the two material, they're made from same material, or two objects made from same material, but the two values are same, you always compare the percentage difference and percentage uncertainty. The percentage uncertainty we calculated, which was 0.66%. That was a previous answer. How to calculate the percentage difference? Percentage difference, when we are calculating a percentage difference, it is maximum minus minimum divided by the standard value. Like the difference of the two values divided by the standard value into 100. So difference in the two value 8.5 minus our value was 8.47 divided by standard is 8.5 into 100. This will give us the percentage difference. So that percentage difference is 0.35%. So percentage difference is smaller compared to percentage because the percentage uncertainty was 0.66%. So when the percentage difference is less than percentage uncertainties, the values are same or two objects have the same value. So we can say that this material as a percentage difference is less than the percentage uncertainty. So this mass will be made from brass. What if our percentage difference was higher than percentage uncertainty? Then we'll say no, the percentage difference is more than percentage uncertainty. So for such questions, whenever you are comparing the result for such question, it's always the case whenever two values comparison is there, you always find percentage difference and the total percentage uncertainty and you compare them. So this was Unit 6 from June, or you can also say October 2020 session.